Hello and welcome to this next video in the Cisco Cloud Fabric Launchpad series. I'm Paul Stryer from the Solutions Readiness team, or SRE for short. In this video, we will walk through the steps to build a manual Layer 3 underlay to be used for your cloud fabric. You could choose to use Meraki Dashboard to create your underlay for the fabric, but it will only create a Layer 2 STP-based underlay, which is not scalable in a large network and is not really considered a fabric underlay. So today, I hope you are very excited because we are going to go deep into the networking world and build an OSPF underlay with VLANs, VRFs, OSPF, SVIs, static routes, and many other really super cool technologies. By the time we are finished with the full video series, we will be leveraging EVPN as the control plane and the VXLAN as the data plane to create a unified, highly scalable, and resilient network fabric. So let's go build a Layer 3 fabric underlay. Let's take a quick look at where the network stands at the start of this lab. And if you remember, in the first video, we talked about the 3 phases of the cloud fabric build. Phase 1 is where we start. The network is racked and stacked. iOS is set to 17.18.2. The network at the top of the drawing is our Fusion router and 2 handoff switches. This network is fully configured with OSPF in Area 1 and BGP northbound out to the internet. In the lower bluish section, we have the fabric with 4 layers of switches. At the top, we have 2 switches that will act as our borders. The borders are at the edge of the fabric and connect us to the outside world. Next, we have 2 switches that are traditionally would have been called the core layer. And once we configure the fabric, we will call these the spine, and they will become our route reflectors. Below that, we have 5 switches that are traditionally called our distribution layer switches, and once we configure the fabric, we will call these the leafs. Notice on the left-hand side, we have 2 switches for leaf 1, which are set to be a stacked set of switches. And below that, we have 5 switches that are traditionally called access switches. For our use case, we are going to call these our floor switches. And of course, below the access switches, we have clients. At the start of the lab, all of the switches are defaulted or write erased. All connections in the fabric are set as trunks in native VLAN 1 and allow all 1000 VLAN. There is a DHCP server on handoff switch 1 and has a pool in the range of 10.204.253.0/24. All the switches and clients got addresses from this DHCP server and can ping everyone on the network and the internet. That is phase 1. Moving to phase 2, we will switch all of the interfaces from layer 2 to layer 3 routed and set it up as OSPF. Now that the stage is set, let's go move the network from phase 1 to phase 2 and build our layer 3 underlay. To get this video started, I will just show you very quickly the network is built and operational as a layer 2 network. I'm in the Meraki Dashboard at the SRE Meraki Lab organization and in the Cloud Fabric Pod network. Clicking on Switching and Switches, we'll switch over to our switching page and see a list of all of our switches. In here, we will notice that all of the switches have the 253 network address from the DHCP server on handoff switch 1. Now let's take a look at the handoff switch that has the DHCP server on it. I'm going to start out with a show IP interface brief, and you can see that VLAN 1 has the 253.1 address, which is the default address for the entire network right now in phase 1. The rest of the addresses on the SVIs we'll talk about later when they become relevant to our build. You can also see that 15.1 is going northbound to the Fusion router. Next, I'll do a show IP route, and we'll see that there is a static route going northbound to the Fusion router as well. Again, once we build the underlay, we'll start seeing some OSPF information in this routing table. And now I'll do a show IP DHCP bind and just show you that all of the devices below this have got their addresses from this DHCP server. When we start switching over the underlay into a layer 3 interfaces, we'll statically assign these IP addresses and they will no longer use this DHCP server unless you're going to do like an RMA and need to bring a new device onto the network, and it will initially use this DHCP server as well. And next I will ping .100, which is a client down at the bottom of the network, all the way at the bottom, and then I'll ping Google just to show you that we can also ping northbound out to the internet. Switching over to that client that we pinged from the handoff router, you can see with an IP config that we got the .100 address, which is the one we pinged from the handoff router. Now I'm going to ping the handoff router from this client. Even though we already know it's going to work, I'll just do it just to prove that it is actually working. Alright, we have that working, so let's move on. Randomly switching over to the Spine 01, I'm going to go to Cloud CLI and open up the CLI. From there, I'm going to do a show IP interface brief, and this will give us an idea of what the address is on the SVI for VLAN 1. In this case, you see that we have an address from the 253 network, which we got from the DHCP server on handoff 1. The next thing I'll do is I'll do a show IP route, and we'll take a quick look at what's in my routing table. The main most important thing is that we have a default route, or the all zeros, going to the .253.1 address, which again is the handoff router. All of the switches in the network have that as their static route right now at the phase 1. Now I'm going to do a show VRF just to show you that it is defaulted for the VRFs. We'll be adding VRFs as part of the fabric build. Now I'm going to just ping real quick the handoff router just to show you that I can ping the handoff router, and that is successful. Now we'll do a show span, and I want to show you that we're using multiple spanning tree protocol and not rapid spanning tree protocol. We will switch to rapid spanning tree protocol as part of our switch over to the layer 3 handoffs. So we'll do that during, but right now we're in MSTP. That's really what I wanted to show at that part. Now let's take a look at the switch stack. Going to switching menu item and then switch stack, we can take a look at how those two leaf number 1 switches are stacked. This came up automatically as soon as I brought them into the network because of the stacking cable that's on the back of them. I click on stack 1 here, which is the name that it default gives it, and you can see that I have the 2 switches that are in the stacking mode. It's very simple. It just came up this way, but it's really simple to add if they're not already connected. Okay, so let's start the layer 3 underlay build now. The first thing I'm going to do is I'm going to shut off all the ports southbound on the leafs so that the access switches and the clients are no longer connected to the network. This way we have less things that are going to have to reconverge when we switch from MSTP to RSTP. Okay, so now let's go to switching and switch ports in the left-hand side menu. This will take us to the list of all the ports for all of the switches. This will be faster to turn them off than doing it one at a time from the main switch window. So I'm going to go ahead and search for leaf 01, and then I'm going to see all the leaf 01s on the left. Now be careful, because sometimes because of LLDP you'll see other switches in this list. But what I'm going to do is I'm going to go to the upper left hand corner and I'm going to click the check box for all of the ports, and then I'm going to unselect the ones that I don't want to turn off, because I'm going to turn off all the ports but a few. Now be careful, because some ports in here will be listed because of LLDP that aren't part of leaf 1. But I'm going to go ahead and uncheck the ones that I don't want to turn off, and then leave the ones checked that I do want to turn off. Then I will click the edit button in the upper left hand side. Again, be very careful here and don't leave checkboxed the ones that are like your uplinks. You want to keep those on, otherwise you'll lose connectivity to that switch, and then you're going to have to hit the button on the front to right erase it and have it come up again with a new config. And that's why you see me going back and forth in here and just double checking that I have the right ones unchecked. And notice that these are not part of the switch that I'm trying to turn off now, so I'm going to uncheck those to leave those ports on. Long story short, I'm going to leave the northbound ports on and the southbound ports off. Okay, I have them all checked. I'm going to go to the top, click Edit, then I'm going to scroll down on the pop-up window, click Disable, and then click Update. This should turn off all of the southbound ports, leaving the northbound ports turned on. Okay, now that that's done, let's change our search to Leaf 2 and start the process over again. So now we're going to do Leaf 2, and again, leaving the northbound ports unchecked and the southbound ports checked. Once you get all the southbound ports checked, click the Edit button, scroll down, click Disable, and Update. Okay, I'm gonna fast forward the video and go ahead and do Leaf 3 and Leaf 4 and join you again after I'm done turning those ports off for Leaf 3 and 4. Now that all 4 leafs have all their southbound ports turned off, now we're gonna do what's called VLAN pruning. This is where we're going to take it from 1 to 1,000 VLANs on every single trunk down to just 1 VLAN or VLAN 1. So I'm going to go to Switches and Switching and Switches in the menu, and then bring up the switches list. The reason we're doing VLAN pruning is because we don't need 1,000 VLANs and using that processing power to do that, especially when we're switching over from MSTP to RSTP. So I'm going to go to Leaf 1A, and once that opens, we're going to see the graphic at the top. We'll see that only one port is being used right now, so I'm going to click on that blue port, number 1, in the graphic. When I click on it, we're going to see down below that it is in native VLAN 1, and it allows 1 to 1,000. So I'm going to click the Edit button on the right hand side, and in here I can take and reduce that down to just 1 VLAN. Now we're going to keep the native VLAN as 1, but allowed VLANs will be 1. Once I edit it, I'll click Update, and it brings me back to the Leaf 1A window, and you can see that the allowed VLANs is 1. Now I'm going to go up to the breadcrumbs in the upper left hand corner and switch to Leaf 1B. Now remember, 1A and 1B are the stacked switches, so now I'm going to go to 1B, and when I do, I'm going to click on the blue link for port number 1. Notice it has the up arrow, which makes it the uplink port to Meraki. I'll click Edit, and once I hit Edit, I will edit the allowed VLANs down to 1 and click Update just like I did before. Again, when I get back to the switch, you'll see that it has a native VLAN of 1. Then I'm going to click the switches breadcrumb, and I'm going to go to Leaf 2. And then, or actually, I'm going to go to Leaf 2, and then I will do the same thing over and over again until all of the switches have VLAN 1 as they're allowed. I'm going to click on port 1, but notice there are 2 ports active on this switch right now. So I'm going to click the first one, and then I'm going to click the Edit button, and when I click the Edit button, I will go ahead and edit the value just like I did before. Again, I'll edit the allowed VLANs down to just the number 1 VLAN, and then click Update. Now notice when I get back, you'll see that it says allowed VLANs 1, but now I got to go click on the second port, number 2, and then click Edit again and do the same edit that we've been doing so far. So I'll click Edit, I will edit the port or the allowed VLANs and click Update. Now you can see that it has VLAN 1. I'm going to go ahead and stop the video, and I'm going to do the edits for Leaf 3, Leaf 4, both spines and both borders. Now I'm going to do this for all of the ports for all of these switches, not just one, but do it for all of them. On the northern borders, we're going to do some other things that I'll show you in a couple of minutes with our VLANs, but for now let's just get all the VLANs pruned down to just 1 allowed VLAN on the trunks. Okay, so I lied. I came back after I finished the leafs, and now I'm going to go to switching and switch ports, and I'm going to do the spine and show you how to do it using the ports instead of using the actual each individual switch. So now I'm going to go into switching switch ports, search for spine 01, and from there I'm going to check the boxes for the ports that I want to make VLAN 1 as the allowed VLAN. So again, I'm going to check only the ones that I want on spine 1 that are needing to be in VLAN 1. Again, this is just another way to do the same thing. So instead of doing it at the switch and on that little graphic at the top, I came into the ports section and I'm selecting the ports that I want to set the allowed VLANs to 1. Obviously, having a good plan before you start building the fabric and having a good topology drawing are very important to doing this, because you can be looking at the topology drawing so that you know which ports you need to do this to instead of just doing it to all of them. Once you have all the checks selected for the ports that you want to do, hit Edit in the upper left-hand corner, change the allowed VLANs to 1 and click Update. Same kind of thing as we did before, just we're doing many ports at once instead of doing one at a time. Okay, this time I really will stop the video, do spine 2, and I'll do border 1 and 2, and I'll get right back to you. Okay, all of the trunks have been pruned to VLAN 1. Now on this jump host, which is outside the fabric, sitting off of handoff 1, you can see I have a ping to every single one of the devices, the 2 borders, the 2 spines, and the 4 leaves. So now we can just watch these as we build the underlay so that we know when a switch has been converted from layer 2 to layer 3. Okay, so the next step in doing the layer 2 to layer 3 transition is to switch from MSTP to RSTP. So very quickly, let's just jump over to one of the switches. I'll just pick one at random. I'll pick on spine 1. And then I'm going to go into the Cloud CLI, and from there we can take a real quick look at the spanning tree. So I'll go to Cloud CLI, click the launch terminal, and in here I'll do a show span. When I do a show span, we can see at the top that it says MSTP. That's all we really need to see. From here we're going to switch it to RSTP. This conversion to RSTP will happen for all of the switches. We will also set some priorities so that spine 01 becomes the root and spine 02 is the secondary on that. So let's go change them to RSTP. I'm going to go to the switching menu and then switch settings. From in here, this is where we can set up our priorities and also set it to RSTP. So I'm going to click the set the bridge priority button down here and add a new section. Now it's telling me we're going to make some disruptions, that's fine. And then I'm going to go ahead and select spine 01 from the list. Once I select spine 01, I'm going to drop down the arrow for bridge priority and select 4096 for the priority on this one and click the confirm button. Next I'll add the set priority button again, so that we add a second one. From the drop down menu, I will select spine 02 and select the bridge priority of 8192. From there I'll hit confirm. Now we have our 2 priorities set. I'm going to click the RSTP radio button, and then I'm going to go back and notice that it adds a new field called VLAN list. So I'm going to click the pencil next to the first priority and put in 1-4094 to put in the list of VLANs, and then I will click the confirm button. Once I click that confirm button, I have to hit the pencil button for the second priority and add the VLAN list there as well. So it'll be 1-4094 in this one as well. Then I will hit the confirm button to save it, and on the left hand side I have to hit the save changes button to enact the changes that we just created. I gave the switches a few minutes to go ahead and update, so let's go to switching switches in the menu, and then we'll go back to our list of switches. In here I'm just going to select another switch, and since we did spine 1 the first time, I'll probably just go ahead and use spine 1 for this one as well. I'm going to open the Cloud CLI, click on Launch Terminal, and then we will do a show span again like we did last time, and in here we should now see that it is RSTP, and it is. You can also see the bridge priority that we set, and you can see that this is also the root bridge. Alright, let's click on the breadcrumbs and go to spine 02. When I get to spine 02, I'm going to go to Cloud CLI, launch the terminal, and then do a show span. We will see that RSTP is active on the switch. We'll see the priority that we set, and we'll see that this is not the root bridge, but we do see that there is a root interface. And predictably, T118 is the root port going to spine 01, which is the root bridge. Next, we need to configure OSPF and set up our areas. This is the phase 2 logical topology drawing of our network. Notice we have area 1 at the top, area 0 in the middle, which is the fabric, and area 11, area 12, area 13, area 14 south of the leaf switches. In this next section, we will configure our areas and turn on OSPF in our Meraki Dashboard. Returning to our Meraki Dashboard, I'm going to go to Switching and OSPF Routing. When I go to this page, it is off by default, so I will have to enable it. There is a set of buttons at the very top, disabled and enabled. I'm going to go ahead and click the enabled button now. Notice that some of the defaults are already set for us, including our area 0. There has to be something in here, so they leave it at area 0 backbone, but I'm going to click the add button and I'm going to add our next area. In this case, it's area 1, and I will give it the name of handoff. Next, I'm going to hit the add button again, but this time I'm going to hit it 4 times because I know I have 4 more areas that I need to add. Then I'm going to go ahead and put the numbers in for the 11, the 12, the 13, and the 14 areas, and then I will give them their name. I will fast forward through naming the areas. Now that we have the naming finished, we have to set the types. The first 2 are normal, but the ones that are in the access portion need to be stubby, and we would do totally stubby, but they don't have that in Meraki yet. That'll be somewhere down the road, so we'll check stub for now. Once all the OSPF settings are done, we'll click Save at the bottom to save these settings. The border's northbound interfaces are at the edge of the fabric and connect the fabric to the outside world. We will need to set up the correct VLANs for various links to have the correct data flow. We also need to be very careful. It is very easy to make the wrong configuration change and disconnect our switches from the Meraki dashboard. Remember, all these switches are in cloud configuration mode, which means the switches are fully configured from the Meraki dashboard. And if you lose connectivity on the UAC uplink port, you will no longer be able to manage the switch. If this happens, you'll have to physically go to the switch and long press the button to reset the switch. Also, if you remember, every switch in the fabric right now is in phase 1 or in VLAN 1 with a trunk that allows VLAN 1 only. So if you got rid of VLAN 1 northbound from the borders, you would lose connectivity to all switches in the fabric. Looking at the phase 2 physical topology, you can see we are going to make some changes to the VLAN structure north of the borders. On port 1014 of border 1, you will notice we are going to configure VLAN 1, VLAN 3, and VLAN 7. And on port 1013 on border 1, we are going to configure VLAN 5 and VLAN 9. On border 2, port 1014, we are going to configure VLAN 1, VLAN 2, and VLAN 6. And on port 1013, we are going to configure VLAN 4 and VLAN 8. Notice on port 14 on both switches, we still have VLAN 1. We need to keep VLAN 1 up throughout the whole process of converting the fabric ports from layer 2 to layer 3 routed ports. Otherwise, we will lose connectivity. After the layer 3 underlay is fully implemented, we technically could remove VLAN 1. But I like to keep it so if we need to do an RMA, I can bring a new switch into the network relatively fast and relatively easy. Okay, let's jump in and configure some VLANs. On the menu, I will go to Switching and Switches to go to the switch list. Once I'm at the switch list, I will select my first switch, which will be border 01. By default, I'm on the summary page. And from the summary page, I will click on one of the ports that I want to start with. In this case, I'll start with port 13. And once I'm on 13, you can see that it is allowed VLANs 1, native VLAN 1. I'll click the edit button on the right hand side, and from there I will change the allowed VLANs from 1 to 5 and 9. Once I've entered the allowed VLANs, I'll click the update button and it will take me back to the summary page for border 1. From here, I will click on port number 14, and as you can see, 14 is allowed VLAN 1, So I will go ahead and click the edit button like we did before, and then I will change the allowed VLANs this time to 1, 3, and 7 and click update. Once I'm back to the Border 1 summary page, I'm going to go to the breadcrumbs and click the arrow to the right so that I go to Border 2. Then, just like before, I will click number 13, and as you can see, number 13 has VLAN 1 allowed. I'm going to go ahead and change this to 4 and 8, and then I will click the update button once again. Now that I'm back to the summary page, I'll click on 14, and I will do this once again. I will click the edit button, and then I will go to the allowed VLANs, and I will make it say 1, 2, and 6 this time. Once I enter those values, I will click the update button and we'll go back to the summary page. We're now done with the northbound VLANs for the borders. The next step is where we start creating SVI ports and enabling OSPF on the border switches. At this point, the UAC port on border 1 is via port 1014 to handoff 1 switch. But on border 2, the UAC port, which again is the port that connects us to the Meraki Dashboard, on border 2, it's on port T101. That connects to spine 01 and then to port T111 to border 1 and out port G1014 to handoff switch 1. We now need to know which ports are the UAC ports because we're about to start converting which ports are the UAC ports, and it is very important that you are very meticulous on how you choose to do this, or you could lose connectivity to the Meraki Dashboard. When doing this conversion, we need to start at the top and work our way down to the pyramid. Most people would want to start at the bottom and work our way up, but in this case we could lose connectivity. So we're going to start at the top, work our way down. Based on the STP priority that we set earlier in the lab, all of our UACs are going up and out the left-hand side, so we'll convert the right-hand side first and work our way to the left and then down. Also, we need to save that last port on border switch 1, which is port G1014, for the very last one to be converted. This makes sure that all devices have access to VLAN 1 to get out to the internet so that they can get to the Meraki Dashboard before we convert that last leg. So remember, it is imperative that you know where the UAC ports are at the start, and you start at the top and work your day down to keep yourself from disconnecting from that Meraki Dashboard. Our next step is going to be to convert the northbound port on the two borders to the correct VLAN and move the UAC ports to the ones of those ports that we've converted to those VLANs. During that conversion, we'll also enable OSPF in Area 1, which is where handoff switch 1 and 2 are also configured. Okay, let's go configure some SVIs and OSPF. To get started, we're going to go to Switching and Routing and DHCP. Once we're in this section, we're going to go ahead and click the Add Interface button. And when we click the Add Interface button, then we're going to have to fill in a new form. The first one we're going to fill out is we're going to select Border 2 from the first drop-down menu. Again, I'll select Border 2 here. Next, I will enter a name. In this case, I'll name it Border 2 to Handoff 2, which makes sense. It's a very easy to understand name, which is something you should do here. Next, I will put in VLAN 4 for my VLAN. And again, I got this number by looking at my topology drawing. Let's have a talk about the preferred uplink checkbox. This checkbox decides which port on the switch is going to be the UAC or Meraki Dashboard link. You have no choice but to have this checked for the very first converted port on the switch. The GUI will not let you remove it unless there is another port on the switch that is the UAC port. Again, there always has to be at least one port that is checked so that it is the UAC port if you're going to convert any of the ports. We want this to be our UAC port, so I will leave it checked. And again, I have no choice since this is the first converted port on the switch. This checkbox would allow me to move the UAC port to another port later on if I wanted to. So now, that this box is checked, let's move on to the next field, which is the subnet field. In the subnet field, I will put 10.204.250.16/31. And from there, I'll just go over to my topology drawing, make sure I have the correct addresses. It looks like I do have those correct addresses, and we'll need .16 as well for our interface. So let's go back to our GUI here, and let's put in the interface address, which will be 10.204.250.16. And then of course we'll have to put in our gateway, which will be the next number up, which is 17. The next thing we're going to do is we're going to put in our DNS addresses. In this case, we're going to use the umbrella addresses of 208.67.2222 and 208.67.220.220. Then from there, we need to go ahead and do our OSPF settings. We're going to go ahead and do the drop down for our areas, and we're going to select area 1 for our handoff. Let's confirm on our topology drawing that we have the right area. Looks like we do, so now let's go back and finish up where we need to set up our OSPF network type, and we're going to set that to point-to-point so that we don't have the elections for DR and BDR. We're just going to go straight point-to-point and then click Save Changes. Now back at the interface view, you can see that we have our first SVI for SVI4, and we have a static route or an all zeros route to .17. So we're good to go. Let's continue on with the next SVI. We're going to do the same thing over again, and I'm going to click Add Interface, and I'm going to select Border 2 again to set up the next SVI. So after selecting it, I will give it a name. In this case, we're going to have it say Border 2 to Handoff 1. The first time we went to Handoff 2, now we're going to Handoff 1. We're going to put VLAN 2 in the VLAN section. Notice that the preferred uplink checkbox is not checked automatically for us because we already have it checked on the other SVI or SVI4. So in this case, if we didn't check this, SVI4 would still be the preferred uplink. But in this case, I'm going to go ahead and check this box to show you that I can move it from one SVI to the other so I can point the UAC to another direction. Also notice when I check the box, what happens to the number of fields that I have below that. Right now there are only 2 fields. When I check it, it adds in some more, including our DNS. So I'll go ahead and put in the subnet of 10.204.250.12/31. Then the interface address is the /12 interface. Next, I will fill in the gateway address, which is the .13 IP address, and that is going to the handoff 1 router. Now, from here, you notice that we have our DNS information already filled in because we filled that in on the first interface that we set up. So next we're going to need to set up our OSPF. So we will select area 1 for the handoff area, and then we will set the network type to point, so again we don't have to have the DR and BDR elections and all that stuff because it is a point-to-point connection. Then I'll click Save Changes. Back to the main routing page, you'll notice that we have 2 SVIs, one for 4 and one for 2. But notice that the default gateway has now changed from the handoff 2 router to the handoff 1 router because that's where our UAC port was also changed to. Let's go do some testing. I'm going to go to Switching and Switches to go back to the switch list. And then from there, I will select my switch. In this case, I'm going to go ahead and select switch border 2 so that I can go do some testing and see if those 2 ports are acting as if they are SVIs. So I'm going to go to Cloud CLI and I'm going to bring up the Cloud CLI. The first command that I'm going to do here is a show IP OSPF neighbor to see that we are connected with the 2 handoff switches, which we are. The 1111 and the 2222 are the OSPF IDs for those two switches. The next command I'm going to do is a show IP route, and you're going to see that there are OSPF routes as well as two links for the default gateway, one going to each one of the handoff switches. So that is correct in what we should be seeing. From here, I'm going to do a show IP OSPF database, just so that we can see what's in the database and if things are starting to look right there. And we have our type 5s there at the bottom and our type 1s. So again, it's still looking the way I think it should look. The next thing I'll do is I'll check out the static routes, and I'll do a show run pipe include IP route. What you want to see here is a static route with an AD of 120, which we do. Next, let's take a look at where our UAC port is. I'll do a show UAC uplink command, and we're going to see that this is on VLAN 4, which is going to handoff 2, which is what I want because it's on the right hand side. And for now, all the other UACs are going to VLAN 1 through handoff 1. So this one we're connecting through handoff 2 to make sure that we keep things safe so we don't lose connectivity to the dashboard. Okay, now it's time to go build two more SVIs, and we're going to do those for border 1. So I'm going to go ahead and go back to switching and then go to routing and DHCP, which is where we will add those two new SVIs. But before we do that, I'm going to edit SVI VLAN 2, and I'm going to go ahead and check the box for the preferred link or preferred uplink to make this VLAN 2 be the link that connects us to Meraki. I'm doing this just to show you that I can move this once it's already set up for configuration. So I'm adding in the gateway interface. The OSPF information is still configured, and I'll hit Save Changes. Okay, let's add the other two SVIs. I'm going to click Add Interface. Then I'm going to drop down the menu here and select border 1. Before we did border 2, now we're doing border 1. So then once I select border 1, I'm going to go ahead and put the name in, and the name will be border 1 to handoff 2. Next, I'll put in the VLAN. In this case, it'll be VLAN 5, and then we're going to go down and do the preferred uplink. In this case, notice that it's already checkboxed. Remember, the first time you do an SVI on a switch, there has to be at least one, so it won't let you not put that checkbox in, so we'll leave that checked because I have no choice. The next thing we'll do is put in our subnet. In this case, it's 10.204.250.14/31. Next, we'll put in our interface IP, which is 10.204.250.14. Next, we'll put in our gateway of 10.204.250.15, which is the handoff router side. And then from there, we'll put in our two umbrella addresses for our DNS servers. Now let's go take care of our OSPF. In this case, our area is still going to be in area 1, or our handoff area. We'll select that. Then we will select point to point like we will for all of our OSPF throughout the whole entire fabric. And then we'll click Save Changes. Now we can see that there is a SVI for VLAN 4, VLAN 2, and VLAN 5. We can also see which ones have the preferred uplink by looking over to the right there. And we also see that there's a new static route. Okay, let's go add one more SVI by clicking Add Interface. In this case, we're going to select border 1 again like we did last time. We're going to go ahead and put in a name, and in this case, we're going to call it border 1 to handoff 1. And from there, we will add VLAN number 3. I'm going to make VLAN 3 be the preferred uplink, so I'm going to do the checkbox. Notice it wasn't checked when we got here because we already have one for border 1. I'm going to go ahead and fill in the addressing information and then continue from there. Okay, now let's do the OSPF. Again, this will be area 1 handoff, then we'll put it at point to point, and then we will do a save changes. Now notice that we have a 4, 2, 3, and 5 VLAN SVI, and the top one, number 4, and the bottom one, number 3, have our preferred uplink, and we have our 2 static routes. All right, let's go do some testing. I'm going to go to switching and switches, then I'm going to select border 1, and from border 1, I'm going to go ahead and go into the Cloud CLI. Once I'm in the Cloud CLI, I'm going to do a show IP OSPF neighbor, and then we'll see that we should see both of our handoff switches, which we do. So now let's do a show IP route, and from there we should be able to see OSPF showing up in our routing table, as well as having 2 paths for our default gateway, which we do have. Now let's do a show IP OSPF database, and this will just show us what's in the database for type 5s and type 1 traffic out here, and you can see it's starting to grow a little bit compared to what we saw last time, which is good, and it will grow each time we add a switch into this. And then we're going to do a show run pipe include IP route, just to make sure we have that static route configured with the 120 AD on it. And if we scroll up there, we see it at the very top of the list. Then the last thing we'll look at is our show UAC uplink. This will show us that hopefully VLAN 3 has our UAC uplink to the Meraki dashboard, and it does. Let's take a quick look at the topology drawing to show what we did here. So as you can see at the top, between the border and the handoffs, we created 4 SVIs. We created one for SVI 3, one for SVI 2, one for SVI 5, and one for SVI 4. And when we created those, we told the one for SVI 4 and for SVI 3 to be the uplinks, or the preferred uplinks, to get to the Meraki dashboard. The next set of configurations we're going to perform are to convert the ports between the border switches and the spine switches to layer 3 ports and set our preferred links to our Meraki dashboard. And as we did earlier, we'll enable OSPF, but this time we'll be in area 0. We need to be careful and make sure we do things in the correct order as to not disconnect our switches from the Meraki dashboard. So to do this, we will configure port T112 on border 2 first, then port T112 on the spine 2 switch to layer 3 with OSPF. Port T112 on spine 2 will become the UAC port, since it is the first one we will configure on the switch. From there, we'll move on to the links between border 1 and spine 2, doing the border first, then the spine. Next, we'll configure port T111 on border 1, going to spine 2. And as you might guess it, we will configure port T112 on spine 1 next. And finally, we'll configure the connection between border 1 and spine 1, top down, border then spine. And as I zoom out, we can confirm that this section is in OSPF area 0. Before we configure the port on border 2, let's just cruise over to spine 2 real quick and look at where the UAC port is and what the ports are configured like, just so that we know and we can confirm that we're not going to lose connectivity by configuring the wrong port. So I'm going to go to Cloud CLI on spine 2, and once I'm in the terminal, I'm going to do a show LLDP neighbor. And this will just give us an idea of which ports are connected to which devices, so we can see where we need to be connected when it comes time to start changing these ports over to layer 3. More importantly, let's look at where our UAC port is by doing a show UAC uplink, and you can see it's on port 8. Now we're going to be working on the port going to border 2, and this is port 8 going to spine 1. So we're good to go on configuring this. So back at the switch list, I'm going to go to border 2. Something I like to do before I do each port is to do a ping to the address that I'm going to be configuring. And this particular jump host is out connected off of the handoff switch in a service container. So this is outside the fabric. I'm pinging in. Notice I can't ping because we haven't configured this port yet. But once we configure it, we should see this start to ping. Okay, so here I am back on border 2 in the Meraki dashboard. I'm going to click on the summary button on the left-hand side there to go back to the graphic that shows our ports. Then I'm going to click on T112 because that's the port going down to spine 2. From there, I'm going to click the edit button on the right-hand side, and this will take us into the edit function of this port. Now from here, I'm going to click routed port at the top and click update. Now when I click this update button, it's going to go back to the summary page, but then it's going to go to the routing and DHCP page and start a entry for a new interface on here. So it automatically takes us here. We don't have to worry about it. So here I'm going to go ahead and put in the name of this particular interface that we are going to configure here. And this particular name, I'm going to name it border 2 to spine 2. Notice that the preferred uplink checkbox is not turned on. This is not the first port that we've configured for this switch. And we're going to leave it unchecked because this is a southbound port, not a northbound port going towards the internet. So then I'm going to put in the IP address of this particular interface. A few seconds ago, I started a ping on my jump host. And that address that I was pinging is the same address that this interface is going to be. And I did that so once this configuration gets pushed to the switch, I should see the ping become successful. Like we did before, we now need to set up our OSPF settings, but this time we're going to select our area 0, and then we're going to set it point to point like we're going to do all of them, and click Save Changes. Returning to the main page, you'll see that we now have a layer 3 port for border 2 to spine 2. Now I'm going to jump over to the jump host, and you can see that we are now pinging .26. Returning back to the switches page, going to switches and switches, we will go back and look at border 2, and then we'll go to the port itself. So I'll click on T112, and when I do that, you'll see that it no longer says VLAN 1 native and VLAN 1. It will say it is a routed port with IP addresses and an IP address on the interface. So now let's return back to the cloud CLI for this border 2 and run a few commands to confirm it has done what we expect it should be doing. So I'm going to do a show IP route, and we should start to see OSPF routes in here, as well as a static route that is there by OSPF. The next command that I'll do here is a show UAC uplink. And when I do that, we will see that the uplink has stayed where it's supposed to be, which is going northbound. It should not be going southbound. And as you can see, it's still on the VLAN that we put it on going northbound, which was VLAN 4, which is where we set it. So now I'm going to do a show run pipe include IP route. This will give us a list of all of the statically configured routes in the config, and if we scroll back to the top, we should see one default gateway with an AD of 120, and we do. The next command that I will show will be a show IP OSPF neighbor. And as you can see, we can see our neighbors out of this OSPF, which is good. The next command that we'll do is the show IP OSPF database, just to see that we have the same database that we've been seeing elsewhere, and it's looking good and growing a little bit each time we add a new device. Just to make sure we have our bearings, let's go back to the topology. We just did border 2 T112. Now we're going to do spine 2 T112, and that will become not only a layer 3 port, it'll also become the UAC port for spine 2. That's why we did border 2 first before we did Spine 2 to make sure that we didn't lose connectivity to the Spine 2 device. Now that we're back at the dashboard, I'm going to click on the breadcrumbs to go back to the switch list, and I'm going to click on Spine 02. Then we'll go into Spine 02, and I'm going to go into Cloud CLI just to make sure that our UAC is going out port 8 and not out the port we're getting ready to go to, and then we'll switch it from where it is now to the new routed port. So in the Cloud CLI, I'm going to hit Launch Terminal, and I'm going to do a Show UAC Uplink. Then we should see that the UAC port is going out port 8 and not out of the port we're getting ready to configure. So now let's go configure that port. So going back to summary, I'm going to click on port T112. That's the port that we want to convert over that's going to border to. So now I'm going to hit the edit button, and if you notice, it's on VLANs right now. VLANs allowed. So we're going to click on edit, and then we will click on the routed radio button, and then we will hit update. Remember when you hit update, it's going to take us back to the summary, but then it's going to take us to the routing and DHC page and do an add interface like we were doing before, but it takes us directly to this page. From here, I'm going to go ahead and put the name in, which will be Spine 2 to Border 2. From there, we're going to scroll down, and I'm going to leave the checkbox clicked because we have to. We have no choice because the very first interface has to have that checkbox on, which basically says this is going to be the uplink port. I'm going to fast forward the video and start again after the addresses are put in. Now that the addresses are in, we need to do our OSPF. So scrolling down, we'll select our area 0 for our backbone. We'll select point to point, and then we'll click Save Changes, as we've done a few times already before. Now back at the list of interfaces, we'll see that we have 2 routed interfaces. We've done one for border 2 facing down to Spine 2, and now we have one from Spine 2 back to border 2. When you weren't looking, I started a ping to the 27 address, and now we can see it just started pinging, so we know that that switch just got its configuration and then brought that interface up. So now it's routed and the UAC port's going across it. Returning to the dashboard and Spine 2, let's take a look at what happened. I'm going to click on T112, and you can see that it's no longer a VLAN trunk, but it is a routed port with a .27 address. Now, let's go to Cloud CLI and take a look around. I'm going to go to the terminal, and from the terminal, I'm going to do a Show UAC Uplink. And when I do that, it will show us where the uplink has moved to. So there's the uplink, and we can see it's where we expected it to be. Next, I'm going to do a Show Run Pipe Include IP Route, or just route. And this will show us the routes that are statically in place, and we can see that there's one in there with a default route with a 120 AD, which is good. That's what we were looking for. Next, we're going to do a Show IP OSPF Neighbor so that we can see what neighbors we're seeing. And we see the neighbor, which is our border 2. From here, we'll do a Show IP OSPF Database, and this one will show us our database of before it goes into the routing table. And as you'll notice, as our OSPF network grows, you'll see that there's more entries in this table each time we run it. We're seeing the type 5s at the bottom and the type 1s at the top, so that's good. That's what we should be seeing. Next, let's do a Show IP Route and make sure we start seeing OSPF entries as well as our static route. We'll see 2 on the next time we do this, but for right now we should see 1 static route. I'm going to click on the switch breadcrumbs and go back to the switch list and click on border 1, because now we're going to do the border 1 side of Spine 2 connection. So again, we want to start at the top and work our way down. So we're going to do border 1 first. As you know, I like to get a ping going to that port before I configure it, so I went back over to my jump host, and I'm just going to stop the ping that's going to the previous port, and I'm just going to hit up arrow, erase that 27, and put in a 22, which is going to be our next interface. So I'll get that ping going, and then we'll go configure that on border 1. So back at border 1 summary, I'm going to click on T112, which is the connection going to spine 2. Notice it is a trunk with VLAN 1. I'm going to go ahead and click edit, and then click the routed radio button just like we've done before, and click the update button. Remember, that's going to take us back to here, but it's also going to take us to the add interface page over in the routing and DHCP section. It automatically takes us there, which is super cool, because otherwise I'd probably forget. Then I'm going to go ahead and put our name in. Remember, this is border 1 to spine 2, so we're going to call this one border 1 to spine 2 in the name. Scrolling down to the IP management, I'm going to leave the preferred uplink unchecked because we don't want the uplink to go southbound to spine 2. And then we're going to put in our subnet information. I'll fast forward when I'm done with this, adding the addressing. Now that I have the addressing in, it's time to scroll down and do, you know what, the OSPF settings. So scrolling down, I'm going to select area 0, which is where we are with this, and then we're going to put it in point to point. It's kind of getting repetitive, isn't it? We're going to do this a bunch more times before we're done with the underlay. So now I'm going to click Save Changes. Now back at the list, we can see there are 4 SVIs and 3 routed ports. We just added that bottom one, border 2 to spine 2. Now flipping back over to our jump box, let's see if we have pings starting to happen to that switch. Any second now, we should hopefully see it. Up, there they go. We now know that that switch has the config that we just configured, and it's now pinging successfully. Returning to the dashboard, I'm going to go ahead and go to switching switches to go back to our switch list, and then we can go to border 1 and do some investigation. So in here, I'm going to go back to Cloud CLI, and from Cloud CLI, I will start doing some show commands to see that our configuration change actually did happen. So the first one I'm going to do is do the show UAC uplink. This should not have changed. We should still see a northbound to VLAN 1, which we do. So now let's go ahead and do now I'm going to do a show IP route. This will let us know if we are getting OSPF information into our routing table. If we scroll back to the top, we should start seeing some O's there on the left. We should also look out for our default route that we got from OSPF, and it looks like it is there. Next, I'm going to do that show run pipe include IP route. Again, this will just show us that we have a bunch of static routes in our config, along with that default route with the 120 AD at the top. There it is, we can see it. So let's move on to the next command. The next command is going to be the show IP OSPF neighbor. From here we should be able to see 2 neighbors, and we do. So the next one will be the show IP OSPF database. We should see this starting to grow more and more each time we do it. It looks like it has grown by a few, and let's move on. Now we have to configure the other side of that link that we just configured on border 1, and that would be spine 2. So now when we get to spine 2, I'm going to go ahead and flip back to my jump box, and we'll set up the ping like we always do so that we know when the config is pushed. So I'm going to stop the previous ping. I'm going to get this one set to 23, and then I will go back and we'll start configuring spine 2. Notice that their pings are failing because there is no 23 yet. That's what we're getting ready to go to configure now. Here we go again. Just like before, we're going to click on T111, which is the link going to border 1. Notice that it is allow VLAN 1 and a native 1, so we're not routed yet. I'll click edit on the right hand side, and then we will click routed port and click update, just like we've done a few times before. Once we click that update button, it's going to go back to that main page. Then it's going to flip us over to the add interface page, where we're going to start entering in the details for this interface. For this interface, we're going to call this named spine 2 border 1. We already have an uplink port, so we're going to leave the uplink port unchecked, and then we'll start putting in our interfaces. And again, I will fast forward to after I'm done putting in the addresses. Now let's go ahead and scroll down and set up our OSPF settings. Again, this is in area 0, and then we will make this point to point, and then we'll click Save Changes. When we click Save Changes, it's going to take us back to the list page, and we should see now that we have 4 routed interfaces and 4 SVIs. Now let's jump over to the jump box and see if we are pinging. Look at that. We are pinging, meaning the config has made it to the switch is configured, the port has come up, it is routed, and now we have a pinging successful to that address. Let's head back to our switches by going to Switching Switches, which takes us again back to our switch list. I'm going to go ahead and hit on Spine 2, which is the port we just configured, and then I'm going to click on port T111, and we can see that it is now a routed port with an address of .23. Now moving over to Cloud CLI, I'll go ahead and open our terminal and we'll run a few commands to confirm. So now I'm going to do a show IP route. We should be able to see some O's on the left hand side letting us know that we have OSPF here, which we do, and we should see a default route, and we see 2 routes, which is what we should see, one to border 1, one to border 2. So now we can do equal cost multipathing. Now we'll go ahead and do a show UAC uplink, and we'll see that the uplink is on port T112 is going to border 2. Next, let's do a show run pipe include IP route. Again, we'll see a bunch of static routes. We should see the default route with an administrative distance of 120, which we do. So now let's move on to the next one, which will be a show IP OSPF neighbor. And we should see 2 neighbors, which are our border 1 and our border 2. And look at that, there we go. We have the 2 that we should see. Now let's do a show IP OSPF database. Once we run this command, we should see that it's looking good and the database is looking good and growing as we expected. Let's click the switches breadcrumbs and go back to the list, and let's go to Spine 1 and do some investigation before we start moving forward. We want to see where that UAC port is on Spine 1 before we go to border 2 and configure it and start changing over to layer 3. So going to Spine 1, we're going to go to Cloud CLI, go into Terminal, and do a Show UAC Uplink. We should see this going out T111, which is northbound to border 1, which it is. So now we are good to go. We know where the UAC is, and when we're done with this, it's going to go out to border 2. But for now, we're going to have it go to border 1 and keep it there for the few seconds. Real quickly, let's just double check that we have the right port. Let's go over to our Cloud CLI and we'll do an show LLDP neighbor just real quickly to make sure that T111 is really going to border 1, or to Spine 1, sorry about that. And yes, it is. So now let's go get our ping going. We want to get a ping going to .24 because that is going to be the address for this port on border 2 going to Spine 1. Hopefully this ping will fail, and let's see, and it does. Okay, so now we have a failed ping, and now we're going to go configure that port so that it will be successful when we come back. Alright, returning back to the summary page in Meraki Dashboard on border 2, I'm going to go ahead and click on T111. Of course, I'll ping on T112 just to show you that it is routed. Now let's go back to T111 and let's click on the edit button so that we can turn it into a routed port. I'm going to go ahead and click routed port and click update. And just like it did the last few times, it's going to take us right to the add interface page on the routed and DHCP page that we were using earlier to do our SVIs. So now we want to fill in the name. For this one, it's border 2 to Spine 1. And again, I will scroll down, leave the checkbox unchecked because we don't want this to be the preferred uplink. I'll fill in the addresses and get right back to you. Like we did before, we'll select area 0 for our OSPF area. We'll set the port to point or our network type, and then we'll click Save Changes. And then from there, we'll be taken back to the list, and we should see the list growing here. Now we have 5 routed interfaces and 3 static routes. Flipping over to our jump host, let's see if our pings will start any second now. Hopefully it will. 3, 2, 1. Oh, there we go. Now the pings are started, and we know that we have a successful config down to the switch. Going back to the dashboard and then going to switches, we'll go back to our switch list, and again we will select border 2 so that we can go confirm our configurations that we just sent to border 2. So clicking on border 2, I will go there and then we'll click on T111, and we will see that it is now a routed port, whereas before it was a trunk with VLAN 1 allowed only. Now you can see it has a .24 address, so we're good to go. Now I'm going to go to Cloud CLI, and we will do a show IP route, and let's see what's there. So we should see some O's on the left, and we should see that static routes at the top that are learned by OSPF, and it looks like things are looking good here in the routing table. Next, let's do a show UAC uplink. We should see this going over VLAN 4 up to handoff 2, and we see that. So the next thing we're going to do is a show run pipe include route or IP route, and this will show us our static routes that are in the configuration. Here is our list of static routes, and we see at the top we have a gateway last resort going with a 120 administrative distance. That looks good. So now let's go ahead and do a show IP OSPF neighbor, and let's see what our neighbor statements look like. Again, that's looking good. We're ready to go. We have these 3 that is correct. The 27 address is the spine 2 address, and then the 111 and 222 are the handoff switches. So now let's do a show IP OSPF database, and let's see how that's looking now that we've added another switch to the list. It looks like it's growing and looking good. I'm not going to explain this. You can stop the video and look at it closer, but it's looking good to me. Let's return to our jump host. Let's stop the previous ping, and now let's change the ping to .25, which will be the spine 1's address going towards border 2. So now let's make sure this fails, and it does. That means that we don't have an address there, but we will shortly. Back at the dashboard on spine 1, let's go ahead and click on T112, which is our next port going to border 2. So now I'm going to hit edit on this port. You can see that it is allowed VLANs, which means it's a trunk. I'm going to click the routed port radio button and click update. Again, this is going to take us to the page that will allow us to add this interface. Next, I'll add the name, which will be spine 1 to border 2. Then I'll put in the IP addresses. Notice that that checkbox for preferred uplink is checked. That's because this is the first interface that we're configuring on this switch, which means we're going to have more information we need to put in down below for our addressing. I'll fill in the addressing and get back to you in a second. Now that all the addressing is in, again, we have to do the OSPF. Again, this is in Area 0, just like the rest of them have been. I'll select Backbone Area 0, then I will click Point-to-Point Network Type, and then we'll hit Save Changes. When we get back to the list and scroll up there, we should now see that we have 6 interfaces that are Layer 3 routed interfaces. As you can see, the ping to .25 is successful. Again, we now have a successful transfer of the config from dashboard into our switch. So now let's go do some more investigation. Back at dashboard on spine 1, let's click on T111, and you'll notice that it's still a routed port. We're going to do that one next when we go to border 1. But now let's click on T112, and we see that this is the routed switch port that we just configured to .25. Now let's go do some show commands in the Cloud CLI. I'll open the terminal, and then I'll do a show IP route, and then we'll see hopefully some OSPF routes in the table. And let's scroll up, and I'm starting to see some O's on the left, and I see our default route that we learned via OSPF. So let's move on to the next command, which will be a show UAC uplink. Remember, we clicked that checkbox when we created this routed port, so hopefully we'll see it on this port, and yes we do. T112 is the uplink port, which is what we set it for. Now let's do the show run pipe include IP route or just route, and either one will work. Will show us our static routes that are in our config, and we see the all zeros default route with the 120 administrative distance. That is good. So now let's do a show IP OSPF neighbor, and let's make sure that our neighbors are starting to fill in, and yes, we have a neighbor going to border 1. So now let's do our show IP OSPF database and see how that's looking. As we've seen on other switches, this is growing as we grow our database, and look at this, it is growing. So again, you can stop the video and look at this, but again, I'm going to move on because I know that it looks good. Now we have a little detour to make at the crossroads. The last link we have left on spine 1 is the link going to border 1. But we have a conundrum here, and as my college professor used to say, it would behoove you to take a different path, Mr. Stryer. And in this case, it would behoove us to slow down and return to this last link on spine 1 after we've configured all of the leaves as routed ports. And I bet you're asking yourself, but why, Mr. Stryer? Why can't we just keep going and finish up the spine before going further south? And here's why, Grasshopper. That link is the only link carrying VLAN 1 right now. If we make that a routed port, VLAN 1 will no longer exist and all the leaves will lose connectivity to the dashboard. So, if we go configure all the leaves first and make all of their right side links to border 2 routed and the UAC port, all of the leaves will no longer need VLAN 1. And then we convert all the left side links to spine 1 to layer 3. After that, we can return to that link between spine 1 and border 1 and convert it to layer 3. And lastly, we will hit that cross patch on port T118 on both of the spines to a layer 3 link. So Grasshopper, let's go configure us some leaves and forget about that last spine to border link until later. Next up, we are going to configure spine 2 interface G104 connected to leaf 4. And then we'll configure leaf 4 interface G102. Before we make this conversion, leaf 4's UAC port is G101 going to the spine 1 via VLAN 1. And after the conversion, G102 interface to spine 2 will become the UAC port. Remember, we're going to do this top down, so spine, then leaf, to keep from disconnecting leaf 4 from the Meraki dashboard. First up, let's go back to our jump box and let's go ahead and start that ping. Now this ping will be to spine 2's interface G104, which will become .42 address. So let's go ahead and ping that, and we can see that it is pinging, but it's not successful, which we expect. Returning to spine 2, on the dashboard, we're going to go into Cloud CLI and do a show LLDP neighbor just to confirm and to be safe that G104 is the interface going to leaf 4. And we are correct, so we can move on safely. Now that we've confirmed the interface, back on the summary page, if I click port 4, we can see that this is in a trunk because it says allow VLAN 1. Let's go over to leaf 4 real quick and just take a quick look and make sure we know where the UAC port is. So I'm going to go to leaf 4, and you can see that the up arrow is on port 1, which that link is going to spine 1, so we're good to go. So going back to spine 2, we're going to go ahead and start making this transition. So I'm going to click on port 4. Again, we see that it is allow VLAN, so it is a trunk. We're going to go ahead and go to edit, and then we will click routed port. Then we'll click update, just like we've done a few times before. And remember, this automatically takes us to the add interface page where we're going to add the information for this port. So again, I'm going to go ahead and give this a name, which will be spine 2 to leaf 4. This is spine 2, and spine 2's UAC port is going northbound. This is a southbound port, so we do not need to check the preferred uplink port. I'll go ahead and add the IP addressing and get back to you in just a second. Next, I'll scroll down to the OSPF section, and this is where we're going to select Area 0. Again, we're still in Area 0 with all of our fabric information. So after I select 0, I will go ahead and select point-to-point for our network type and save changes. This will return us to the list of interfaces. Now be careful here because it always defaults to 10 rows. You need to add the rows with clicking the down arrow over on the lower right hand side so that you can see all of your entries. I'll select 30 here, and you can see now I have 7 interfaces and I'm ready to move on to the next one. But before we move on, let's jump over to the jump host and make sure that we're pinging that new port that we just configured. It just came online, it just got its configuration, so we're now confirming that that port is up and active. So now let's just go do a few show commands over at the Meraki Dashboard. Back to the dashboard, I'm going to go to switching and switches and go back to our switch list, and of course we're going to go over to spine 2. So in here I'll click on port 4, and you can see that it is a routed port with .42 on it, and from there, guess what? We're going to go over to Cloud CLI. It's kind of starting to get repetitive, but I like to check every single time before I move on just to make sure everything's working. So now I'll do a show IP route. We'll confirm that we're seeing OSPF routes. We'll make sure that we have our default gateway learned from OSPF. We'll make sure that we have all the interfaces that we have been adding in here in the OSPF table. Next, let's do a show UAC uplink. Now this should be out T112, and it is. It's going northbound, not southbound. The next thing we'll do is a show run pipe include IP route, or sometimes I'll just type route, sometimes I'll do IP route. Anyways, it'll show us the static routes, it'll show us the gateway of last resort with the AD of 120, which is what we are looking for. Next, we're going to go ahead and do a show IP OSPF neighbor, and from here we should see our 2 northbound neighbors, which we do. So now let's go ahead and move on to a show IP OSPF database, and as we've been seeing, this kind of has been growing with each time that we add anything. This is looking good, so I'll go ahead and move on to the next section. Now it's time to convert the leaf 4 to spine 2 connection. So let's jump back over to our jump host. Let's create the ping to .43, which will be the interface on leaf 4. And we'll make a continuous ping. We should obviously not get a ping right now because this address does not exist. So let's go make that address exist. Let's go back to the Meraki dashboard. Let's go to leaf 4. So I'm going to click on the switches breadcrumbs, head down to leaf 4, click on that, and now we're ready to start moving ahead forward on leaf 4. On the summary page for leaf 4, I'm going to click on port 2. We can see that it is a trunk port, and we can see with the up arrow on port 1 that it is the UAC port. But let's go into Cloud CLI and confirm that. Let's do a show UAC uplink, and we will see that port G101 over VLAN 1 is where the UAC port is at right now. So that's good because we're going to make port 2 the UAC port in this next section. I'm going to do a show LLDP neighbor just so I can confirm that port 2 is the one that we want going to spine 2. Okay, so now let's go convert that port. I'm going to click on summary page again, click on port 2, and then I'm going to click the edit button just like we've done before in the past. Then I'll click on the routed port and then click on update. I think you're starting to hear a theme here by the same thing over and over and over again. So now that I'm on the add interface page, I'm going to go ahead and put the name in of leaf 4 to spine 2. And now this is going to be the first routed port on this leaf, so the checkbox is automatically checked for preferred uplink. So now I'm going to put in the IP addressing, and I'll get back to you in just a couple of seconds. Now that I've put in all the IP addressing, let's scroll down to OSPF. Let's put this thing in area 0. Let's set our network type to point, and then click Save Changes. As always, we'll be returned to the list. The list is set to 10 rows by default, so you'll need to increase that to see all the items in this list. Now we can see that there are 4 SVIs and 8 routed ports. The list is growing as we add these ports. Let's confirm our changes. I'm going to go back to the jump host, and as always, we're waiting for the pings to start to that new port that we just added. And here we go. We have a ping to .43. So that is successful, so we know that our configurations have made it to the switch from the Meraki Dashboard. Let's finish our confirmations by going back to Meraki Dashboard. I'll go to Switching Switches to take us back to the switch list, and then I'll click on Leaf 4. From here, I'm going to go ahead and click on port 2, and you can see that we now have the .43 address, meaning it is a routed port. So now let's go over to Cloud CLI and let's do a show IP route, and let's see what's looking like in our route table. We have a bunch of O's on the left hand side. We have our gateway of last resort, all zeros, learned by OSPF, and we'll get another one of these gateway of last resort addresses from OSPF once we get the spine 1 connected. Next, let's do the show UAC uplink, and we should see this on port G102, which we do. So now we know that we have the correct UAC. We're no longer using VLAN 1. So now it's safe to do spine 1. Now let's do a show run pipe include IP route. And you can see that we have the all zeros route with a AD of 120. So we're good on that one as well. Next, let's do the show IP OSPF neighbors and see where we stand with those. We have our first one, and we'll get a second one once we bring up spine 1. Next, as always, we'll just do the show IP OSPF database just to confirm that we have the database looking correct as we have in the past. Again, this looks correct, so we'll move on. Let's have a quick refresher of what we've done so far. We started out on border 1 and border 2 northbound ports and put the correct allowed VLANs on these trunks going northbound to the handoff switches. We also put these SVIs in OSPF area 1. This created 4 SVIs in the Meraki Dashboard, as well as pushing these new configurations down to the switches. Next, we converted all the ports between the borders and the spines, except for the connection between border 1 and spine 1, so we could keep VLAN 1 active for the leafs. We also did not convert port T118 on both spines because this connection also carries VLAN 1. Both of these links will be converted once all these leaves have been converted to layer 3. At this point, we have created 4 SVIs and 6 routed interfaces. The last thing we did was convert port G104 on spine 2 and port G102 on leaf 4, making that the UAC port for leaf 4. Now we have 4 SVIs and 8 routed ports. Since this is becoming so repetitive, I'm going to stop the video and configure ports G101, 102, and 103 on spine 2 to leaf 1, 2, and 3, and I will restart the video when I move on to spine 1. Okay, I've finished all of the spine 2 to leaf connections, so now I'm going to go to leaf 4 and we're just going to do some observations on how it's connected to spine 1, because now we're going to do all the spine 1 conversions. So now I'm going to do a show LLDP neighbor, and from here we can see that G101 is the one that's going to spine 1. Next, I'll do a show UAC uplink, and we should confirm that port G102 is the one that's going to spine 2 for our UAC port, which it is. So we're good on that. So now let's go convert our spine 1 port 4 going to leaf 4. Let's confirm that by going to Cloud CLI. We'll do a show LLDP neighbor. Again, this is overkill, but I just like to make sure that everything is correct before I make changes. And I've confirmed that G104 is the one going to leaf 4. So now going back to summary, clicking on port 4, then we'll click edit, just like we've been doing along this whole path. So click edit, click the routed port, and click update. Again, this will take us to the Add Interface page automatically. And here I will put in the name. The name will be Spine 1 to Leaf 4. So I'll fill that in, and then we'll scroll down to the IP section. I'm going to leave the preferred uplink unchecked so that G102 remains the UAC link. I'll fill in the addresses and start the video after I'm done. Alright, now that I'm done with that, we'll do OSPF of area 0. We'll do the network type of point to point and click Save Changes. When we're back at the list, I will set the rows to 100 so we can see them all. And then you'll see that we have 4 SVIs and 15 interfaces that are routed interfaces because I added all the rest of those for Spine 2, and now we just added the first one for Spine 1. Now let's go back to the jump box and confirm that we are pinging that new address. So the new address was .40, and it looks like we are pinging, so the configuration has made it to the switch. So now let's go confirm the rest of the details. Returning to the dashboard, I'll go to Switching Switches, and then I will go down to Spine 01. We'll click on port 4 and confirm that it is a routed port, and we can see that it has the .40. So yes, we have a routed port here. So now let's go to Cloud CLI, let's do our show IP route, and from here we should see the table has grown significantly, and you can see there's quite a few more O's on the left hand side. You can see we have our gateway of last resort and the learned by the OSPF, and we can see all of our local and learned OSPF routes. Next, we're going to do the show, run, pipe, include IP route. This will show us our IP static routes that are in the config, including the all zeros route with the administrative distance of 120. Now we're going to do our show IP OSPF neighbor. We should only see one here, and we do, because remember that first port we're keeping as a layer 2 VLAN 1 port, so everybody has access to the Meraki Dashboard. We'll do that one last. Now we'll do a show IP OSPF database, confirm everything's looking good here, and it is, so let's continue on. Let's return to our jump box and go ahead and set the ping up for that port that's going to be on leaf 4, and we're going to put this to .41 and do a continuous ping. We should see this fail because, again, we have not created this port yet. Returning to the dashboard, we're going to go to leaf 4 and go to the Cloud CLI, and again, just real quickly for an abundance of caution, I'm going to do a show UAC uplink. We'll see that the uplink is going out port 2, but it's port 1 that's going to Spine 1, which is the one we're going to be configuring now. So we're good. Now we're going to do a show LLDP neighbor, and we see that 101 is the one going to Spine 1. Returning to the summary page, I will click port number 1, which is the one going to Spine 1, and then as we've done many times before now, I'll go ahead and click the edit button on the right hand side. And when we get into this pop-up window, we will click the routed port radio button and click update. And again, as always, this will take us immediately to the add interface page, and then I'll put in the name. This one will be leaf 4 to Spine 1. Scrolling down to the IP4 section, I will leave the preferred uplink unchecked because we're going to leave port 2 as the UAC port. I'll add the IP information and start the video again in a few seconds. Next, we'll scroll down to the OSPF section, choose area 0, then we'll do our point-to-point network type and click Save Changes. This will take me back to the list. I will add the rows in so we can see all of the interfaces, and you can see we have quite a few. At the very bottom, you see the leaf 4 to Spine 1 created. Let's start the confirmation process by going to the jump host and confirming we have a ping to that new address, which was .41. And we can see that we have a ping there. Returning back to the dashboard, I'll go to Switching Switches to go back to the switch list, and then I will go down to leaf 4, and then I'm going to click on the port that we just converted, which was port number 1. So I'll click on that in the summary page, and we can see that we now have a .41 routed port here. I'll go to Cloud CLI, launch the terminal, and in the terminal I'll do a show IP route. We should be seeing a bunch of routes via OSPF, including our 2 gateway addresses that we learn, and we'll see many addresses in the list because our list is growing as we add these ports. Next, let's confirm that our UAC port stayed on 102. So I'm going to do a show UAC uplink. And from there, we should see that port 102 is the uplink, and it is. Next, I'll do the show run pipe include IP route, and then we'll see the static routes that are in the config again, as well as we'll see the default route with the administrative distance of 120, which we should see. Next, we're going to do a show IP OSPF neighbor, and this time we should see two neighbors because we now have spine 1 and spine 2 as our neighbor for leaf 4. Next, I'll do a show IP OSPF database, and we'll just check to make sure things are looking healthy in there, and for the most part they have been, and we'll see that it does look good and things are progressing with the database. Let's jump back onto the logical topology drawing for phase 2, which is where we convert all of the layer 2 connections to layer 3 in the underlay. So far, we've converted all of the connections on spine 2 to layer 3 except for port T118. That's the cross connect to spine 1. We have also just converted the connection from spine 1 to leaf 4. Since this is a repetitive task, I'm going to stop the video and configure port G101, G102, and G103 on spine 1, and of course the ports on the other side of the connections of each of the leafs for leaf 1, leaf 2, and leaf 3. Okay, I'll be right back after I configure the 3 remaining leaves on spine 1. Welcome back. While you were gone, I configured the 3 remaining ports on spine 1 and the leaf ports on the opposite side of those 3 spine connections. As you can see here, we now have 16 interfaces between the 2 spines and 4 leaves. And all of them have been validated that their configurations are working as expected. Now that all the leaves are configured and no switches in the fabric are using VLAN 1 to get to the Meraki dashboard, we are going to convert the last 2 legs from layer 2 to layer 3. The first one we will convert is the connection on port T118 on both the spine 1 and spine 2. This is the cross connect between the 2 spine switches. As we have done many times before, we're going to go back to the jump box, and then we're going to ping .19, which is going to be the T118 port on spine 2. It's not pinging, which we had expected not to since we haven't configured that port yet. Returning to the dashboard, going to Cloud CLI for spine 2, we're going to do a show UAC uplink just to make sure we know where it is, and it's on T112 where we expect it. Now I'm going to do a show LLDP neighbor just so we can see that port T118 is going to spine 1, which it is. So now let's go back to summary, then we're going to click on T118, and then we will click on the edit button. This is repetitive, we've done this many times before, and again we're going to do it again. So now we'll come here, click the routed port, click the update, and this will take us directly to the add interface page as it has done in the past. From here, I'm going to put in the name, which is spine 2 to spine 1. This is that cross connect. Then we're going to scroll down to the IPv4 management section. We're not going to check the preferred uplink because we do not want this one to become the UAC port. And then I'll fill in the addressing and turn off the video and turn it back on in just a second. Now that the addressing's in, let's go do our OSPF. We're going to select area 0, and then we'll do our network type as point-to-point. Then we'll click Save Changes. When we get back to the rows, we'll have to update the rows so that we can see more than 10. And now we scroll to the bottom and we can see that we have the spine 2 to spine 1 entry in this list. Flipping over to the jump host, we can see that the pings are successful now to 19. So we are good to go with our configuration being pushed down to the switch. Let's go finish confirming this switch is configured by going to Switching and Switches in the dashboard, and then we will return back to the list of switches, and then we're obviously going to go to spine 2. From the summary page, I'll click on T118 and we'll see that it is on .19 and it's a routed port. Now let's go to Cloud CLI and do a show IP route, and let's just make sure that we have routing going on, and it looks like we do. They see a bunch of O's over there. I also see the 2 paths for our gateway of last resort, so things are looking good in our OSPF routing table. Next, I'm going to do a show run pipe include IP route. This will give us our static routes, including that all zeros route at the top with the 120 administrative distance. Now I'm going to do a show IP OSPF neighbor, and I see all 6 that I should see, 2 going north and 4 going south to the leafs. Next, we're going to do the show IP OSPF database and see what's in the database, and what looks pretty much the same as the rest of them. If I scroll up, you'll see there's quite a few entries now that we have so many switches in the database. Let's click on the breadcrumbs and go to spine 1, and let's configure spine 1. First of all, I'm going to click on port 8, and we will see that it is still a layer 2 port. So now I'm going to go to Cloud CLI and just double check that we have everything correct, as I always do. I'm going to show a show LLDP neighbor. I can see that port 8 is going to spine 2, which is what I'm looking for. Now let's return back to the summary page. Then I'll click on port 8, and you'll see that it is a trunk. I'm going to go ahead and click edit. Then I'm going to click routed port, and then I'm going to click update. And again, like always, this will take us to the add interface page. And as I've done a few times now, I'm going to name this one Spine 1 to Spine 2. Moving down to the IPv4 management section, I'm going to leave the preferred uplink not checked so that this does not become the uplink. And then I'm going to fill in the addressing, and I will turn off the video and restart it in just a second. Now I'm going to go to the OSPF, set it to area 0, and then the network type to point. Then I will do save changes. It'll bring us back to the list. I'll set the default rows from 10 to 100, and if I scroll to the bottom, I can see both of my spine connections at the bottom. Back on our jump host, we can see the pings are successful, so we know the config has made it to the switch. So now let's go back to our dashboard, go to switching and switches, and then we'll go back to our spine 1 so that we can see that port 8 is actually a routed port. Now that we see that it's a routed port with .18, now let's go finish our verifications on the Cloud CLI. We'll launch the terminal, and then I'll do a show IP route. We should see a bunch of O's on the left-hand side, but we should only see one route for our all zeros route because we haven't done that last connection yet. And as you can see there, we only have one route so far. When we do that last spine 1 to border 1 connection, we will end up with another route for that all zeros route. So far, all the show commands are showing up as expected. That is a good sign. Next, we'll do the show run pipe include IP route. Again, this will show us all the static routes that are in the configuration, including that one at the top that's all zeros, and it has a administrative distance of 120. Now I'm going to do a show IP OSPF neighbor, and we should see the 2 going north and the 4 going south, which we do. That's looking good. Now we're going to do a show ISPF database and see how that's looking. This command is looking the way it should look. You guys can look at it and compare it to the topology. Let's move on. I hope you are very excited because we only have one more connection to convert to finish up this layer 3 underlay. Of course, we still need to turn on the southbound ports to the access switches, and we'll do that after we convert this last connection to layer 3. That connection is the connection between border 1 and spine 1. This is the one link that was carrying VLAN 1 for all of our leaf switches so they could get to the Meraki dashboard. But now that all the leaf connections have been converted to layer 3, we can remove that VLAN 1 connection and make it a layer 3 connection. Okay, let's stop talking and let's make it so. Returning back to dashboard and already on spine 1, let's just do a little bit of investigation to see where we stand. I'm going to do a show LLDP neighbor, and we can see that T111 is going northbound to the border 1. Now if we do a show UAC uplink, we can see that the uplink is going to port 112, so we're good to go on that one as well. Now let's go back to switches and go to border 1, and now let's do some investigating here, again just to be safe. Now I'm going to go to Cloud CLI, and in the Cloud CLI I'm going to do a show UAC uplink, and we'll see that it's going over VLAN 3 northbound, which is where it should be and where it's going to stay for the entirety of the fabric. Now let's do a show LLDP neighbor, and we should see that T111 is going southbound to the spine 1. So now that we've confirmed all of the ports and all of the UAC ports, let's go back to summary, and then let's click on port 1, which is going south to the spine 1, and let's go ahead and click edit as we've done a million times already. I'm going to go ahead and click routed port and then click update. When I do that, it's going to take us to our add interface again, and I'm going to name this one as border 2 to spine 1. Once I do that, I'll scroll down to IPv4 management, and I'll fill in the IP addressing, leaving the preferred uplink alone because we want that to continue to go northbound over VLAN 3. I filled in the IP addresses, so let's move on to OSPF. In this one, we're going to go to OSPF 0, then we're going to set the network type to point-to-point, and then click Save Changes. Returning to the list of interfaces, I will select 100 for the default rows, scroll to the bottom, and we can see that border 1 to spine 1 is there. Now over to our jump host, we'll go ahead and ping that address of .20 and make sure that it is pinging. It is pinging, and that means that our configuration has made it to the switch. So now let's go and do some more investigating. Back at dashboard, let's go ahead and go to switching, and then return to our switch list. We'll select border 1, and then we'll do a little bit of investigation. First, I'll click port 1, and we'll see that it has .20, meaning it is a routed port, which is what we set and what we were expecting to see. Now let's go do some investigating in our Cloud CLI. Let's go ahead and do a show IP route, and if we scroll back to the top, we'll see that we have 2 paths for the all 0 routes, and we'll see that we had a bunch of O's on the left hand side, and if you were to investigate, you would find that pretty much every one of our connections is now in the table. I'll scroll back down through this routing table, and you can stop and start the video and check it out and compare it against the topology drawing that we have, just to make sure that you see what you think you should see in this routing table. But for now, I'm going to go ahead and move on. Let's go ahead and do that last connection. Going back to switches, I'm going to click on spine 1. This is our last layer 3 connection that we need to create. I'm going to go to Cloud CLI like we've done a few times before, and then I'm going to do a show LLDP neighbor just to see that T111 is going up to border 1, and it is. Returning to the summary page, I'm going to click on T111, and we can see that it is a trunk, so I'm going to click edit. Then I'm going to hit the routed ports button and update for one last time. This will take us to the add interfaces pages, and we will fill in the interface pages. First, we'll start with the name, which will be spine 1 to border 2. In the IPv4 section, I will leave the preferred uplink unchecked as we have in the past because we don't want this one to become the uplink port for this one. I'll fill in the addresses and I'll be right back. The addresses are in. It's time to do one last OSPF settings. I'm going to do area 0, and of course we're going to do network type of point-to-point, and then click Save Changes. This will bring us back to our list. I'll set the default rows to 100 so we can see them all. I'll scroll down to the bottom, and we'll see both the border spine and spine border interfaces at the very bottom. Let's go over to our jump host and make sure we're pinging. And it looks like we are pinging. So again, our configuration has made it to our switches, and we're ready to go do some more investigating. Okay, let's go back to the dashboard, go to switching and switches, go to our list and select spine 1. Then we'll click on port 1, and we'll see that we now have the .21 address, which means it is a routed port. I'll go to Cloud CLI, do a show IP route, and when I do this, I should see a bunch of O's on the left hand side for OSPF, and we should see the dual route all zeros route, which we do. And if you want to start and stop the video, and I'll scroll down through here, you can kind of compare this to the topology drawing and make sure we have all the routes you think we should have. Switching over to handoff switch 01, I'm going to go ahead and do a show IP route, and again you can compare these numbers in the routing table to what we think we should see on the topology drawing, and just check it out and see what you think. You can see quite a few of them are here. I know because I've looked at it, it is correct. I'm going to do a ping, and I'm going to ping both the border and the spine that we just did, just to make sure I can ping it from here, and I can ping both of them from here, so it looks like we're good to go. Now that all of our interfaces are layer 3, it is time to move on to other configurations. The next thing we're going to do is configure what I call the management interfaces for our southbound connections on the leaves. Notice in this topology, we have a DHCP server on each leaf. Also, due to best practices set by the TMEs and the CVD, we are going to set up VLAN 2, and we'll set up local VLANs for each floor. We'll also set up a OSPF area for each of the 4 leaves. So let's go make these configuration changes now. Returning to the Meraki dashboard, I'm going to go to Switching and Route and DHCP. And from here, I'm going to go ahead and click Add Interface, as we've done many times before, but this time we're going to build something slightly different. This time, I'm going to go ahead and select from the switch or switch stack field. I'm going to drop it down and I'm going to select our stack, which in this case it's named stack 1. Once I select stack 1, then I'm going to give it a name. In this case, I'm going to call it Leaf 01 MGMT for management. Then I'll scroll down and fill in the VLAN, and remember we're going to switch it from VLAN 1 to VLAN 2, so we'll go ahead and put a 2 in the VLAN. I will scroll down and deselect the preferred link because we don't want this on this one, and then I'll fill in these addresses. But I'm going to show you something I haven't showed you before. I usually create a sheet like this of all my addressing to go along with my topology. And in here we can see that these interfaces need to be 10.204.251 and 252/25. I'm going to select the 251.0/25 for this first leaf, and then we'll come back and fill in the next 3 leaves with the following addresses. Okay, according to our sheet, we should fill this in with 10.204.251.0/25, and our interface IP is going to be 10.204.251.1. Now let's configure our DHCP server, and we're going to do this as a run DHCP server. Then we're going to set it to 30 minutes because we're in a lab, so it doesn't really matter. In this one, we'll select DNS as using the umbrella addresses, and that's what DHCP will hand out, is the umbrella addresses. Next, we'll set our area for OSPF to 11. That is the one for leaf 1. And then we'll set this to passive and leave it as broadcast. We did everything else as point to point, but this one we're going to leave as broadcast. Once we have this configured, we'll go ahead and click Save Changes, and this will take us back to our interface list. I will set our rows to 100 so that we can see them all. We don't have 100 items here, but we will set it to 100 just because it's faster and easier. Then we'll scroll to the bottom and we should see this new VLAN 2 set up for leaf 1. Next, we need to do leaf 2's management interface, but since this is a repetitive task, I'm going to stop the video and do the next 3 of them and restart the video when I'm done. As you can see, I now have all 4 management interfaces, one for each of the leaves, and you can see that 2 of them are on the 251 network and 2 of them are on the 252 network. As always, let's go do a little verification to make sure that everything is configured the way we think it should be. I'm going to go back to the switch list, and then I'm going to go back to Leaf 01A and go into Cloud CLI. From here, I'm going to do a show run pipe section DHCP. This is going to give us a look at what is in the configuration for DHCP. If we scroll down through here, we'll notice that everything that we expect to be here is here, and so we can move on and do another command. And the other command I want to look at is a show IP interface brief. This is going to show us SVI2, and it's going to show that the IP address that we had, which was a 251.1, but also where the protocol's up or the line is up and the protocol's down. That's because we still have those interfaces on the southbound turned off for right now. For the sake of time in this video, I'm not going to show you performing these 2 commands on the other 3 leaves. I've already done this, and now we're going to move on to the next step. Next, we're going to go to switching and switch settings, and we're going to set the root priority for VLAN 2 on each one of the leafs. So in here, we're going to click the blue hyperlink that says set the bridge priority. When we do that, it's going to add a new field here in the bridge priorities. Go ahead and click the blue button on that one and then start filling it in. First, we're going to select our switch or our stack. In this case, we'll select stack. Then we'll set our priority to 0, and then we'll set our VLAN list. In this case, we're going to set it to VLAN 2. Then we'll click the confirm button. Then we're going to do this 3 more times, once for leaf 2, once for leaf 3, and once for leaf 4. I'll forward the video to the end of this section. Once we confirm all 4 entries, then we're going to click the blue Save Changes button in the lower left corner, and then it will put it into the list. But notice it puts it in as one line because it's saying the same thing for all 4 devices. Next, we're going to select the switching menu option and then switch ports. From here, we're going to search for our first leaf, which is 9300-29. And we're doing this because we're going to set the leaf trunks and the correct VLANs. So we're going to go ahead and search for that switch, and then we're going to check the box in the upper left hand corner so that we select every single one of the switch ports. Then I'm going to deselect any routed ports and any ports that don't belong to leaf 01A. And all the dedicated stacking ports will always be deselected, so you don't have to worry about those. So then click Edit in the upper left hand corner. And once we do that, I'm going to scroll down and I'm going to enter a 2 in the native VLAN. And then from there, I'm going to put in my allowed VLANs. In this case, it's going to be 2 and 11 because remember, VLAN 11 and OSPF 11 are in off of leaf 1. So we'll put 2, 11. Then I will click Update. Now we did that for leaf 1A. We have to do the same thing for leaf 1B. Even though they are stacked, we still have to do both of them. So what I'm going to do is I'm going to go back up to the top and I'm going to search for 9300-28 this time, and we will do the 1B switch. We will do the exact same thing. We'll check the upper left checkbox to select all the ports, then we'll deselect any of the routed ports and any ports that belong to a switch that isn't 1B, and of course the dedicated stacking ports are already unchecked. Once we do this, we'll go back up to the top, click on the Edit button, scroll down until we get to the VLAN section. We will switch the native VLAN to 2, and then we will put in 2, 11, which was what we did in the last one, because remember, this is all part of leaf 1, and then we'll click Update. Alright, now we're going to move on to leaf 2, and I'm going to show you one more because I want to show you that we're going to use 2 and 12 this time instead of 2 and 11. So in the search window, I'm going to search for leaf-02, find all of the leaf 02 ports, and then I will use the checkbox to select them all. But notice in here there are some that don't belong to leaf 02, and that's because the LLDP is showing those. Anyways, I'll select the checkbox, select them all, and then deselect the ones that I don't want to change. Again, be aware and look out for names that aren't the one you've searched on because LLDP will add more in here. And again, the dedicated ports for our stack will be unchecked automatically. So now we'll go back and we'll click Edit and do the same thing as we did before. So we'll scroll down to the VLAN section. We'll put our native VLAN as 2, but this time we're going to put our allowed VLANs as 2, 12. And then we click Update, and that is enough for leaf 2. I'm going to go ahead and stop the video and do leaf 3 and leaf 4 since it's a repetitive task. Leaf 3 will have 2 and 13, and leaf 4 will have 2 and 14. I will be back in just a few seconds. The next thing we need to do is set up our ports on our access switches, which we're calling floor switches. Remember, the access switches have no connection to the Meraki dashboard, so all of the changes we are about to make will be done in the dashboard, but will not be configured on the access switches till they come back online. Notice that all of the northbound ports are 23 or 24 depending on the switch's physical configuration. Also notice all of the clients are on ports 12, 13, or 14 on access or floor switches depending on how many clients are at each one of the floors. So in this section, we're going to bring down all the ports except for 12, 13, 14, 23, and 24 for the floor switches. Then we will configure the correct VLANs for each of these 5 ports. And later in the lab, we will enable the southbound leaf ports connected to the floor switches to bring them back online and connect to the Meraki Dashboard, and in turn, get their new configurations. Returning to the dashboard, we're still in the switch port section, so I'm going to search for floor 01-switch 01. This is the first of the 5 switches that we have as floor switches. Once I have this in my screen, I'm going to go ahead and check the box to check all of the interfaces. Then I'm going to deselect 12, 13, 14, 23, and 24. As we saw before, the dedicated stacking ports will always be unchecked and you can't check them, they're grayed out. Once you get the 5 ports deselected, and make sure you get the right ones because you don't want to turn off the uplink port, then what you want to do is you want to go to Edit, and then you want to click the Disable button because we want to turn all of these ports off except for the 5 we're going to be using, and then click Update. Once you're back to the list of ports, now we're going to select the same ports, but we're not going to select all of the ports. We're going to actually check 12, 13, 14, 23, and 24 because now we're going to set the VLANs for this particular set of 5 ports. Now that you've checked all 5 ports, now let's go to the upper left-hand corner and let's click the Edit button. And when we do, we'll get the pop-up, and then we'll scroll down to the VLAN section. We'll make native VLAN 2, and then we'll put 2,11 into the allowed VLANs and click Update. Since this is a repetitive task, I'm going to stop the video, do the next 4 switches, and then return. Just know that when I go to floor switch number 2, it's going to be 2 and 12. When I go to switch number 3, it'll be 2 and 13, and switch number 4 will be 2 and 14. So the VLANs will change, but the native VLAN will always be 2. The next step is to turn on the ports southbound on the leafs going to the floor switches. So from here, I'm going to go to leaf 1B, click on port 24 in the summary graphic, and then click on Edit. Then I'll select the Enable button and hit Update. That's all there is to it. Now I'm going to show you another way to do it by going to leaf 2. And I'm going to go to Switching Switches, search for leaf 2 because I have 2 ports on here. It's just faster to do multiple ports at one time in the ports list. So I'm going to select 23 and 24. Then I will click the Edit button at the top of the page, and then you will see that there is an Enable switch. I'll turn on Enable and click Update. Since this is a repetitive task, I'm going to just go ahead and turn on the rest of the ports for the rest of the leafs, and I'll get back to you in just a second. As always, let's do a little bit of verification. I'm going to go to leaf 1A, and then I'm going to go to Cloud CLI and do a few commands to make sure that our ports southbound are all functioning correctly. So first of all, I'll go to Cloud CLI, launch the terminal, and then I'm going to do a show IP interface brief. If you remember before when we did this, VLAN 2 or SVI 2 was up and down. Now we should see that it will be up and up because we brought that port up with VLAN 2 on it, and we also see that it got the 251.1 address. So the next command I'm going to do is a show interface trunk and kind of look at what we have as far as trunking information. We can see we have 2 and 11, which is what we configured. Remember on leaf 2 we did 2 and 12, leaf 3 we did 2 and 13, and then 2 and 14 on leaf 4. If I do a show span, you can see that we're RSTP, and we see that our priority is 2, and we can see that this is the root port and all ports are forwarding. This looks good, exactly what I expect to see. So now I'm going to do a show IP DHCP binding, and when I do that, I'll see what addresses this DHCP server on this switch has given out to any requests below. So we can see that there are 3 addresses here. So let's flip over to one of our clients. In this case, we're going to go to Flow 1 Switch 1 and the client that's on port 12. And I'm going to do an IP config all. We're going to see that the address is .21, and we can see that F666 is the last 4 of the MAC address. Let's flip back to the switch, and we can see that that address was given from this DHCP server, so that's cool. Now I'm going to flip back over to another client, which is on port 13, and then I'll just do the IP config once again, just to confirm that this one also got an address from that DHCP server. So we see that we got 23, and it's 86 EC. So we'll go back over to the switch, and we see that that one is here as well. So we know that things are working properly south of the leafs. Let's check one more of the 4 leafs. I'm going to go to leaf 2, and then we'll go to Cloud CLI and terminal once again, and we'll run the same commands. So we will do a show IP interface brief, and from there we'll be able to see that VLAN 2 or SVI 2 is up and up with an address in the range that we expect to see. Next, we'll do the show interface trunk, and we'll see that we have 2 and 12 for our trunks, and things look good here. Next, we're going to do a show span, and this will show us that we have a priority of 2. This is the root bridge, and everything is forwarding. Things look good on this one as well. Next, we'll do the show IP DHCP binding, and we'll see what addresses that we've handed out south of this leaf. We can see that 4 addresses have been handed out from this DHCP server on leaf 2. Let's go take a look at what is on one of the clients and see what address it got. So here we are on the client that's on port 13. I'll do a IP config all. You can see that he got 133 address and 4124 is the last 4 of the MAC address. So let's return back to the switch and see if that's the one that we see. And it looks like it is. So we are in the right place with the right information. Now let's take a quick look at one of the floor switches or access switches, whichever you want to call it. I'm going to go to Cloud CLI, and in here I'm going to do again a show IP interface brief, just so that we can see that the SVI for VLAN 2 is up and up. And we can see that it got an address, and we can see that it is up and up, so we are good there. The next thing I'm going to do is a show UAC uplink, just so that we can see where the uplink is for this particular switch. And we can see that the UAC is on VLAN 2, and it's on port 24, which is where we expect to see it. Now we've finished completing the build of the layer 3 underlay, and here's a quick summary of the things that we did. We started out by turning off all the ports southbound on the leaf switches going to the access switches. We then pruned all the trunks down to VLAN 1 so that when we converted to rapid span tree, we weren't trying to do 1,000 VLANs. We're only doing 1 VLAN on the conversion, and then of course we converted to rapid spanning tree. From there we configured our SVIs northbound on the borders, and then we did the interfaces in the fabric from layer 2 to layer 3 routed using OSPF. At this time, the Meraki Cloud Fabric does not do BGP to OSPF redistribution. So we extended the OSPF up to our handoff switches so that we could redistribute that into BGP to go northbound to the internet. From there, we did the switches from VLAN 1 to VLAN 2 on all the leafs. We set the trunks and allow VLANs between the leafs and the access switches, and then we brought up those southbound ports on the leafs, and then we confirmed that everything in the underlay was functioning as we expected so that we can move on to build the overlay on top of that. I hope you've enjoyed this video and will find it useful when building your next cloud fabric. I look forward to seeing you in the next video where we will build and deploy the overlay using the Meraki Dashboard. This is Paul Stryer. Have a good day.